In this session, we will try to uncover application integration criteria. Enterprise integration is the task of making separate applications work together to produce a unified set of functionality. Some of these applications may be custom developed in-house, while others are bought from third-party vendors. These applications probably run on multiple computers, which represents multiple platforms and may be geographically dispersed. Some of these applications run outside of the enterprise by business partners or customers. Some applications which need to be integrated might not be even designed for integration and they cannot be changed. These are some of the issues what makes integration difficult. So what makes for a good application integration? If the integration needs are always the same, then there will be only one integration style. But like any complex technological effort, application integration involves a range of considerations and consequences that should be taken into account for any integration opportunity. So what are the application integration criteria? The first criterion is application integration itself. If you can develop a single standalone application which doesn't need to collaborate with any other applications, then you can avoid the whole integration issue entirely. Realistically speaking, any simple enterprise will have multiple applications. The applications need to collaborate with other applications to provide a unified experience for its employees, customers, or business partners. And what are the other main decision criteria for application integration? The second criterion is application coupling. Even integrated applications should minimize dependencies on other applications, which allows the other applications to evolve without causing any issues to the other applications in the integrated solution. Tightly coupled applications make numerous assumptions about how other applications work, and when these applications change and break those assumptions, integration breaks. The interface for implementing integration solution should be specific enough to produce a useful functionality, but general enough to change as needed without causing issues for the other applications. The next criterion is integration simplicity. In an enterprise, developers should strive to minimize the changes to the application which needs to be integrated and also minimize the amount of integration code when designing an integrated solution. Yet changes and new code will usually be necessary to produce a good integration functionality. And the approaches which minimizes the impact on the applications might not be a good integrated solution. The next criterion is integration technology. Integration techniques require varying amounts of software and hardware, which are expensive and leads to vendor lock-in. And also it adds burden to the developers to learn these integration tools to use these to integrate different applications. The next criterion is data format. Integrated applications should agree upon a data format or should have an intermediate translator if the applications insist on different data formats. The related issue is data extensibility and evolution, how the data changes over time and how it will impact the applications in that integrated solution. The next criterion is data timeliness. Applications often tend to share data among other applications in an integrated solution. So we have to consider the length of time between one application to another application when the data is shared. The latency in the data can cause other complex problems in an integrated solution, like the data can become stale, and developers should strive to share the data in small chunks rather than waiting for large chunks of data and sending across to the other applications. By then, the data can become stale, which leads to more complex integration issues. The next criterion is data or functionality. Oftentimes, integrated applications do not just want to share data, but also share the functionality. Each application can invoke functionality in another application remotely, and the remote invocation might look same like local functionality invocation, but will have other network related or latency related issues when we have to invoke some functionality which are remotely separated in the networks. The last criterion is asynchronicity. Computer processing is generally synchronous, and when a procedure wanted to share data or call a subprocedure, the assumption is the subprocedure is available all the time. But if the subprocedures are remotely located, then the communication should happen between these two applications over a network. So at times the networks are unreliable, our networks are not available. So in those scenarios, it's better for the calling procedure to operate asynchronously. By asynchronous, I mean we have to invoke the subprocedure, and the main procedure will not wait until the subprocedure is executed. The main procedure will call or make a log request and go on to the other work, confident that the remote procedure will handle the request in the background asynchronously. So these are some of the application integration criteria. Now the question becomes, which integration approach will better address the integration criteria which we have to handle. We will try to uncover in the coming session which integration approach will best suit which criteria we discussed here. I'll stop here.